So this video lesson goes through multiplying together fractions, starting with a review of what a fraction is using the concrete example of a whole pizza and slices of pizza. Goes through why we might want to multiply together fractions in that example. It goes through the process of multiplying together fractions and gives some examples at the end so that before you come to class tomorrow you can be confident in going through those examples. And of course with those examples we include also the solutions. So let's start by looking again at what a fraction is. And starting with a whole pizza, because pizza is a very convenient way of looking at fractions where one entire pizza represents a whole and each of the slices represents a part of the pizza and is usually, though not always, broken down into even pieces. So if we start with a pizza that has 12 slices, our denominator of our fraction is going to be 12 because the denominator represents the entirety of the pizza. And if we're talking about only one slice, then our numerator, representing that small section that we're talking about, has to be 1. If we change it so that we're talking about 3 slices now, we still need to talk about 12 slices as the total number of slices in the pizza, but now we have a slightly different set that we're looking at. We're looking at 3 of those slices instead of the 1. Now if we really wanted to, and we're not going to do that necessarily as part of this video, we could divide numerator and denominator by 3 to create a simpler form of this fraction and change it into 1/4. We're not going to do that for this video because we're going to keep some of these denominators simple when we're looking at it. But in any case, if you use the 3/12, of course, it might always be easier to simplify it to 1/4. So now, getting our first look at the multiplication of fractions, we're thinking at if one pizza has 12 slices, if 3 people each have 3 slices, how many slices then does that have being eaten? Well, we can look at it from a counting perspective. There are 3 slices for the first person. There's a total now of 6 for the second person, and then now 9 total after the third person has had their 3 slices. So in total, we can see that our fraction by counting becomes 9/12. On the other hand, we don't want to have to rely on counting necessarily to multiply fractions together, so we want to look at it from a fraction multiplication standpoint of what is 3 times 3/12. Now we know that this is going to be 9/12 because we've already looked at it with our counting. So that we know that this answer here has to be 9/12. And knowing what the answer is gives us a way of looking at it where we can really see where our process needs to go and sort of double check if our process is correct. Well, we have 3 slices of pizza each in each of those sections, and we need to multiply it by 3 people eating those slices. Now keep in mind here that our total number of slices in the pizza doesn't change. So our denominator is not going to change when we multiply together this fraction with this whole number. And you can see by looking at the numerator of the fraction and the whole number that it appears that we've just multiplied those two together and gotten 3 times 3 equals 9. Let's look at another example and see if that pattern and that recognition holds true. Looking now at a whole pizza, the one pizza still has 12 slices, but now we want to take 1/6 of the pizza. We're splitting it maybe between 6 different people and want to be as fair as possible to give as many people a equal number of slices as we can. Well, we have 12 slices. So of those 12 slices, which is now not going to go in the fraction, we want to take 1/6 of them. Because if we can split it evenly into 6 different groups, then we can give each of 6 different people an equal number of slices of pizza. And at that point, if our multiplication observation from the last slide holds, where we looked at whole number times numerator is equal to the numerator of the next fraction, this fraction should then be equal to 12/6, or to 2 slices. We're going to say, by our observation before, this multiplication should end up with 2 slices as 1/6 of the pizza. And if we take a look at what we know to be true by counting, we can take those 12 slices, divide them into 6 different groups, because this is what we've done before, and end up with that same answer as 2 slices. So once again, it seems that whole number times numerator becoming the numerator of the fraction over the same denominator seems to work. Now let's go one step further. We have a pizza that has 12 slices. We want to take 3/6 of the pizza now instead of just 1/6. Well, remember that 1/6 of the pizza is 2. So 3/6 of the pizza should be 6 slices. And if we look at that from the multiplication again, 12 slices times 3/6 of the pizza. And we can simplify this down to 1/2, but we're keeping it this way at the moment because now our numerator of our fraction is not 1. We want to look at a fraction that's not a unit fraction, the fraction with a numerator that's not 1, which is 12 times 3. Again, following that pattern that we noticed, if we want to keep doing that, whole number times numerator is equal to 36 all over 6, and 36 over 6 is indeed 6. And so now we've made some observations here, and it seems to be true that if we have a whole number times a fraction, we're multiplying the whole number by the numerator and getting to that fraction. And if we wanted to go through and say 12 slices of pizza, 5/6, we would end up with 10 slices of pizza. And so we've looked at some examples of when we would multiply fractions together in terms of distributing pizza evenly. And so now we're going to get to the rule for actually multiplying fractions together. Now for this, we need to start thinking about we might end up with a fraction multiplied by another fraction. 3/5, for example, times 4/7. And we need to consider what happens when we have two denominators. And if you think about the pattern that we noticed where we multiply the numerators together to get the numerator, it seems obvious, and it's entirely true, that we would multiply the denominators together to get the new denominator. So in writing, and with an example in algebra using variables to talk about how we can put any integer that we want into this. To multiply fractions together, we have a new numerator and a new denominator for our answer. The numerator is just the product of the original numerators. The denominator is just the product of the original denominators, and then at the end, we simplify if necessary. Of course, if we have something that multiplies together to be 15/30, we want to reduce it down to 1/2 because 1/2 is much easier to manage and to deal with than 15/30 is. So notice also that we've included a very particular part here where mixed numbers must be converted into improper fractions. Now we're not going to go through an example of why that is in this video, but you need to convert mixed numbers into improper fractions so that the fraction multiplication holds up. Multiplying a whole number part and a fractional part by another whole number part and fractional part, it is much less complicated to convert them to improper fractions, multiply the numerators and denominators, and then have that be your answer. So in algebra, looking down at the bottom here, we use variables to represent any integer that we could possibly use because those integers can change. Apart from b and d, which can't be 0 because you can never divide by a 0, a, b, c, and d can be any positive or negative whole numbers or 0 that we want, as long as 0 is a or c. So our two numerators in this case are a and c. We can see that the new numerator, whatever they are, is a times c. And no matter what the denominators, b and d are, our new denominator is still b times d. So let's look at a concrete example using that, a very similar idea to what we saw before, 3/4 times 5/7. And let's put this rule into practice. When you multiply fractions, your new numerators are the product of the original numerators. The new denominators are the product of the original denominators. So our numerators in this case are 3/4 times 5/7 are 3 and 5. So our new numerator is going to be 3 times 5. Our denominators in this case are 4 and 7. So our new denominator is going to be 4 times 7, just the product of the old denominators. In this case, there's nothing to simplify as our fraction multiplies together to be 15 over 28. And since 15 and 28 share no factors, that is the simplest form that we can make of our fraction. So go ahead and take that rule and look at it and see if you can apply them effectively to these examples that we see here. 3/5 times 2/3, 12/25 times 3/4, and 3 1/5 times 5/7. Well, if we start looking at the example in the upper left-hand corner first, 3/5 times 2/3, we want to multiply together our numerators and denominators to make our new numerator and our new denominator. So 3 times 2 is our new numerator. That is 6. All of that is now placed over the denominator of 5 times 3, which is 15. And we can get to 6/15, so we can simplify it down to 2/5 because we can divide 6 and 15 both by 3. Or when looking at this, we can notice that in our fraction there is a 3 in the numerator and a 3 in the denominator. If we want to cancel those out now, because 3 divided by 3 is 1, and 3 divided by 3 is 1, you can divide numerator and denominator by the same number and produce an equivalent fraction that represents the exact same amount. We can do that and arrive immediately at 2 in the numerator and 5 in the denominator. Will be particularly important looking at the second example that we have in the upper right-hand corner, which is 12/25 times 3/4. And we're going to start that immediately by simplifying the 12 and the 4 in the numerator and denominator of the first and second fractions respectively. 12 divided by 4 is 3. 4 divided by 4 is 1. And so now our new numerator is 3 times 3. And our new denominator is 25 times 1. Since they share no factors, our fraction of 9/25 is in simplest form. Of course, you could go through and multiply 12 by 3 is 36, 25 by 4 is 100, and get to 36 over 100, divide each by 4, and you will eventually get to 9/25 anyway. But if you want to jump that process a little bit and simplify, then we can do that right before we multiply. And now down in the lower left-hand corner, we see an example where we have a mixed number multiplied by a fraction. And we want to convert the mixed number to an improper fraction to make sure that we actually do get to the right answer. So converting 3 1/5 to a mixed number is 16/5. 3 represents 15/5 plus 1 more. We're going to multiply that by 7/8. I'm going to go ahead and do some canceling with the 16 and the 8s, dividing both by 8. 16 divided by 8 is 2. 8 divided by 8 is 1. And we end up at 14/5. Again, you could multiply 16 by 7 and get 112, 5 by 8 and get 40. Divide both of those by 8 because they are both divisible by 8 and get 14/5 one way or another. So once again, to multiply fractions together, your numerator of your solution when you're multiplying two fractions together is going to be the product of the original numerators. And it doesn't matter how many fractions you have. You can have 3, 5, 7 fractions. You're all multiplying together. The product of the numerators is your new numerator. The product of the denominators is your new denominator. And then you just need to go through and simplify if possible and if necessary, and of course convert mixed numbers to improper fractions.